Okay. In this session, in the thermodynamics, we are discussed the various cycles. After that, in the present session, we are going to discuss the various numericals on the different cycles. The content of this session is like this. To understand the numericals on the auto, diesel and dual cycle, table of contents of today's is problems on auto cycle, diesel cycle, dual cycle is like this. Auto cycle, I have solved a few problems. Let us discuss this diesel cycle problems. Any problem in the applied thermodynamics, you have to study the problem twice. Very carefully you have to write. You have to write the given data. First, you go on studying the problem with the correct notations. Diesel cycle means you must write the PV and TS diagram. That is the first case. As compared to the compression ratio, see, compression ratio is 14, cutoff ratio is 2.2. Calculate the year standard efficiency, pressure and temperature of all the salient points. Assume that the pressure and temperature at the beginning of the cycle is 0.98 bar and 100 degree respectively. In this problem, first identification is the which cycle this is. After identifying the cycle, you have to write this, the pressure versus volume diagram and temperature versus entropy diagram. If you write these two diagrams, you will get the 2 marks in the examination. That you must be careful. Means you must write the very neat diagram. After writing the diagram, your work is to write the given data. First cycle as a compression ratio means compression ratio 1 to 2 RC, compression ratio R suffix C is 14. And cutoff ratio is 2. In between the constant pressure heat addition, it takes place. Constant pressure, it is a 1 to 2 is the reversible adiabatic compression process. Here compression ratio comes into picture. And then V1 by V2. V1 is the higher volume divided by lesser volume. If you take the cylinder and piston arrangement, you can observe here the volume will be more. If you draw the piston and cylinder in between below this PV diagram, this piston is in the top dead center is at 1. Piston in the bottom dead center is 2. This is the clearance volume. If the volume after the top dead center, whatever the bottom dead center, whatever the volume is remaining inside the cylinder, no, that remaining volume is called as the clearance volume. I already explained this point in the earlier case also. Now the compression ratio is 14. V1 by V2 is 14. Rho is the cutoff ratio. Always in the diesel cycle, cutoff ratio takes place at 3. Okay. In this process only cutoff takes place. Exact cutoff takes place at state 3. State 3, 2 to 3 is the constant pressure process. Pressure, the heat supply starts from 2 and then goes on, increases and then 50%. After that, at state 3, total cutoff of the heat supply. Means the assumption only we are assumed equal quantity of heat will be supplied. Means if you want to burn the 1 kg of 1 liter of diesel in the engine cylinder, means whatever the quantity of heat will be liberated after burning the 1 liter of diesel, no, that quantity of heat will be supplied to the engine cylinder, so that the variables can be reduced for the time of derivation. Here also the cutoff takes place at cutoff is 2.2. P1 pressure at the initial state P1 is given is here. Assume that the pressure and temperature at the beginning of the cycle is 0.98. Here the beginning of the cycle is this one, state 1. Here the pressure is 0.98 into 10 to the power of 5 Newton per meter square, because he has given in bars. you must convert that into Newton per meter square or else the Pascal, or else you can keep it in the kilopascal. Kilopascal means 10 to the power of 3. 10 to the power of 6 you are converted into kilo means 10 to the power of 3 kilopascals. Okay. 10 to the power of 6 is nothing but the 10 to the power of 3 into 10 to the power of 3. If you take out the 10 to the power of 3 is, that becomes the kilo. Remaining is 10 to the power of 3 only. Right? 100 degrees Celsius is the initial temperature. Initial temperature is starting of the cycle. This one is the initial temperature. Right? Here you are converted the pressure into bars. But here in the temperature, 100 degrees Celsius is given. That 100 degree you must convert it to Kelvin scale. This degree Celsius scale, Kelvin scale. You are once again I am recalling that basic thermodynamics, various scales, Rankine scales, and then the Celsius scale, Kelvin scale. After that, the one more scale is there, no? Rankine, Kelvin, degree Celsius, Fahrenheit scale. Okay, you are converting degree Celsius to Kelvin. Kelvin means 273. By adding the 273, it becomes the 374 Kelvin. And one more good important thing I would like to explore here. Every time I said this, for example, assume that for the air specific heat and specific volume and the universal gas constant and the ratio of specific heats. Gamma is the ratio of specific heats. Cp, the specific heated constant pressure, Cv is the specific heated constant volume, and R is the universal gas constant. Rho is the ratio of specific heats, that is the Cp by Cv. If you divide this Cp by Cv, you will get the gamma. These things you must remember. You won't give it in the examination. If you don't know this, if you don't remember these values, you can't able to proceed in the further. For any problem, if you won't give in the examination, you must be remember this. This is the standard values of the atmospheric air. Atmospheric air will be having specific heat of 1.005 and CV specific heated constant volume 0.718 and 0.287 kilo. All these things he has converted into joules per kg Kelvin. Kilo means 10 to the power of 3. That's why he has multiplied with the 10 to the power of 3 all the values. Gamma is 1.4. If you want to check this value, gamma value, you divide the Cp and Cv value, you will get exactly the 1.4. After this class, you can check it by using your calculator itself. Here is another very important diagram is the temperature versus entropy diagram. In this temperature versus entropy diagram, this PV pressure versus volume diagram also, the same cycle is written in the temperature versus entropy diagram. Both diagrams will be having its own advantage and disadvantages also. Here 1 to 2 is the compression process. Here the volume decreases and the pressure increases. You can observe here. But it is a reversible adiabatic. Adiabatic means the heat will not flow into the system or system to the surrounding. That you are studied in the basic thermodynamics in the first chapter. Okay, here 1 to 2. 1 to 2 is the entropy is same. If entropy is same, then only it is called as reversible adiabatic. That you are observing here in the temperature versus entropy diagram. But in the pressure versus volume diagram, you would not able to find this in the pressure versus volume diagram. Okay, you could not able to find. That's what I am telling. Both diagrams are very important. That's why at the time of solving any problem in the maybe the Otto cycle, diesel cycle, dual cycle, you must be in a position to write both the diagrams. Here in the problems you are writing, also in the derivation, you need this diagram for the derivation. That's why he is keeping 2 marks for these diagrams only, PV diagram and TS diagram. You must be very careful while writing these diagrams in the examination. Okay, it should be very clear and visible. All the salient points should be marked on the cycle. All these things, whatever you are observing from your eyes, you must write it in the examination. After that, yes, asked this in this particular problem. Yes, asked this. the air standard efficiency. Air standard efficiency is also called as Worley efficiency or thermal efficiency or NETA. He may ask, calculate the NETA. NETA is the symbol for the efficiency. Efficiency here in the air standard cycle means that is nothing but the air standard cycle efficiency, or else it is also called as thermal efficiency. Second finding is pressure and temperature of at all salient points. Salient points, why it is called this as a salient point? You see, state 1, 2, 3, 4, 1, all are called as salient points. State 1, pressure P1, V1, T1. State 2, P2, V2, T2. State 3, correspondingly same, T3, V3, and P3. And state 4 also correspondingly, state 4, all the properties like the pressure, volume, temperature, P4, V4, and T4 will be there. These are called as salient points. Means pressure and temperature of P1, T1, P2, T2, P3, T3, and T4, P4, you must find it at the end of this problem. Okay, he has asked this only. Now I'll come to the solution. Till now, what I explained is what's good for all the problems. That's why I am explaining elaborately while solving the problem, what are all the things you are needed, and then how to solve, what are all the things you must remember. If not, yes, the mentioned in the statement of the problem, what are all the things you remembered, I explained very clearly. You must be remember this up to the examination at least. You must remember this for the whole your the career also, because not only here in the mechanical engineering, while designing, while taking the aspects of any automobile industry, if you go to the any automobile industry, these things are needed. That's why I'm explaining very elaborately this. Air standard efficiency. Air standard efficiency of the diesel cycle, as we all know that, directly has taken that 1 minus 1 by R raised to the power of gamma minus 1, rho to the power of gamma minus 1 by gamma rho minus 1. Rho is cutoff ratio 2.2. RC is compression ratio is 14. 2.2, 1.4 is the ratio of specific heats. As I said, CP by CV. Okay. After this, you calculate this by using your calculator. CP by CV 1.005 divided by 0.718. That is the standard value. Okay. Into 2.2 is the cutoff ratio minus of 1. If you calculate this by using your calculator, you'll get the 0.8, 0.5825. That is nothing but if you make it into percentage, you'll get the 58.25% of the efficiency. That is nothing but the thermal efficiency. First finding is over. Okay. First, the whatever he is asking is over. If you calculate this after writing this, you will get the 50% of marks in this problem. For process 1 to 2, isentropic or reversible adiabatic compression process. Reversible adiabatic compression process. You must recall this 1 to 2. Here the compression ratio is P2 by P1 is equal to V1 by V2. That is nothing but the compression ratio RC raised to the power of gamma. P2 is equal to P1 RC raised to the power of gamma. P2 is equal to P1 is given 0.98 into 10 to the power of 5. It is given in bars. At the time of writing the given data, I explained this. 0.98 into 10 to the power of 5 into RC he has given, that is the compression ratio of 14 raised to the power of gamma. He has not given, it is a standard value CP by CV. It is equal to the 39.43 into 10 to the power of 5 Newton per meter square is the pressure at the 2 salient point 2. This pressure illi nodi pressure he has given in the state 1. Now you are found the pressure at state 2. Okay. Similarly, T2 by T1 is equal to V1 by V2 raised to the power of gamma minus 1. V1 by V2 is nothing but the compression ratio, that is RC gamma minus 1. T2 is equal to T1 RC raised to the power of gamma minus 1. T2 is equal to 273. That is 100 plus 270, 100 degrees Celsius he has given, 273 plus 100 373 into 10 to the power of into 14 is the compression ratio, raised to the power of 1.4 minus 1, it is equal to 1071.9191 Kelvin. You must be very careful. Here you are substituted the temperature in Kelvin. That's why you have to write it. The final answer should be in Kelvin only. And process 2 to 3 ISO. Sir, one ನಿಮಿಷ ಕ್ಲಾಸ್ ಮಾಡ್ತೀನಿ ಮಾತಾಡ್ತೀನಿ ಸರ್ ಒಂದೇ ನಿಮಿಷ ಮಾತಾಡ್ತೀನಿ ಸರ್ hello. Process 2 to 3 is isobaric or constant pressure heat supply. Here nothing but the P3 is equal to P2. P3 is equal to P2. No? This P2 you calculated directly, you will get the P3. That's what. And then T3 you are calculated by using this T3 is equal to 1071 by using V3 T3 by V2 T2. Okay. T3 by T2 is equal to V3 by V2 is equal to rho. This cutoff ratio is rho. Okay. T3 is equal to T2 into rho. You'll get the T3 in terms of Kelvin only. Process 3 to 4 is again RC is equal to V4 by V3. RC by rho 14 divided by 2.26. Here P4 you are calculated. Similar manner, whatever the things you are calculated previously, isentropic equation, what I said, this T1 by T2 is equal to P1 by P2 raised to the power of gamma minus 1 by gamma is equal to V2 by V1 raised to the power of gamma minus 1. By using that, the noble equation, you can calculate all the things. Okay, P4 by P3, V3 by V4, rho by RC, you will get the P4. Now T4 also you are calculating by using that equation. In the similar manner, one more, the dual cycle problem is there. Diesel engine working on the semi-diesel cycle. This statement is very, very, very important. You see here, he is telling diesel engine working on semi-diesel cycle. Semi-diesel cycle is a dual cycle. To confuse the students, always they are framing like these sentences in the examination. Okay, you must be very, very careful because first, if you look into this only 1-2 words, it's look like a diesel cycle, but it is not a diesel cycle. It is working on the dual cycle. Here you must be very careful. Okay, semi-diesel cycle. Semi-diesel cycle PV diagram is 1 to 2 is the compression process, 2 to 3 is the constant volume process, heat addition, 3 to 4 is the constant pressure heat addition, 4 to 5 is the isentropic expansion, 4 to 5 to 1 is the heat rejection process. Swept volume he has given, VS, he has given 0.0055 meter cube, and clearance volume 0.00035. Maximum cycle pressure. Maximum cycle pressure is this one, P3. P3 is 60 bar. Fuel injection ends at 60% of the 6% of the stroke. Here, the 6% of the stroke. V4 minus V3 is 6% of VS. 6% of the stroke. V4 by V3, 6% of the stroke. This is the one, again, 6 within this process. After the 6% is process, the cutoff takes place, means the ends the heat supply. Okay, pressure and temperature at the beginning of the compression is 75 degree and 95 bar. Beginning of the compression is this one, state 1, beginning. Beginning of the cycle is beginning of the compression. Previous problem, he has said this beginning of the cycle or beginning of the compression. Okay, this one. And determine the cycle efficiency, mean effective pressure. Here, he has not asked this sealant points, pressure and temperatures, but you have to calculate for this air standard efficiency or efficiency pressure of the cycle. One more clue I would like to highlight here. For these diesel and dual cycle auto cycle problems, you go on solving the problem like a derivation. Whatever the derivation steps are there, according to that, you go on solving the problem. That's also correct. That's also correct. Only if you proceed according to the derivation, you will get the answer. Okay, that is a very important clue you must follow for all the problems of this year standard cycle. Okay, here all the what I said, this the values he has given, this conversion of Kelvin and then this conversion of bar, everything I explained in the previous problem. Now cutoff ratio, rho, V4 by V3 to 2. V4 is 0.005 Vs plus V3 to 2, V3 to 2. 3 to 2 is nothing but the clearance volume. Okay, 0.006 into 0.005 plus 0.0035 divided by 0.0035. You will get the rho of cutoff ratio, that is nothing but the 1.94. Process 1 to 2. From here you are calculating P2 and explosion ratio alpha P3 by P2, that you are calculated. After calculating the explosion ratio, compression ratio you know it, alpha explosion ratio you know it, cutoff ratio also you know it. Gamma he has not given, you must remember that is 1.4 gamma. By substituting all the things, you will get the 62.98% of efficiency. Mean effective pressure also, you substitute all the things, you will get. Okay. I have given one assignment for your the friend. You must submit that assignment within 3 days. Okay. Otherwise, you will be. This subject is a little bit difficult, tough, and also difficult subject, and also this volatile subject. This one is so that as early as possible you write all the homework or the assignment, whatever you call it as. Have given. You write it very sincerely. At least 70% you will get this subject. Now, after writing the assignment, you don't leave. At the time of writing the derivation, you write it. Roughly you write it, and then by go on practicing. Finally, in the examination, you are feeling very easy. Okay. Next topic is gas turbine cycle. Okay, gas turbine cycle. As you all know that gas turbine is a machine which extract the power from the flowing fluid. In the gas turbine, gases at high pressure, high temperature are expanded through the several stages to produce the power. Gas turbine power plants are used for the aviation application and also power generation. See, in the aircrafts, the gas turbines are very, very essential. Maybe aircraft may be any aircraft. If you take any aircraft, the gas turbine must be there. Okay, without gas turbine, nobody can design the aeroplane or maybe helicopter or maybe any aircraft. Okay, and also power generation. In the power generation, maybe steam power plant, nuclear power plant, or maybe coal-based power plant, any type of power plant. If you take without turbine, you can't able to generate the power. Only the thing is here gas turbine. Here is a gas turbine is used. Various types of turbines also there. If you use the power generation in the idle power station, means by using the water from the dam, you are generating the power. No, that type of power generation. There, the idle power plant, they are using the hydraulic turbines. In the steam power plant, like the coal-based power plant and then nuclear-based power plant, there they are using these steam turbines. Here in the naphtha-based power plants and also diesel power plants, there they are using the gas turbines. Okay, gas turbines. Like this, various types of turbines also available. You are the anyhow in the gas turbines and steam turbines. These are the very vast area. In the some of the higher educations, these subjects are there. Okay, I'll stop this now. I'll continue in the next class.